Welcome to SDL for Kids. This is the step 1 tutorial of our 4-step series. In step 4, we're going to go through the whole step 1 to step 3. And if you want to skip to that straight away, you can do that. If you want to take a more slow approach and go step 1, then step 2, and then step 3, then this is the right way to go. And so we're going to get straight into it, which is synthesis, which is where we generate a material. And in our case, it's going to be a color on a screen. So here are the 3 steps for today. In the next 10 minutes, we're going to look at how to create a window on your computer. And then in that window, we're going to render a color or different colors of choice. And then finally, we're going to update the color with different new colors and some new context information. You will not need the microbit for this notebook. It's just all going to be software. So in section 1, we're going to learn how to create a window and fill it with a color. And we're going to use the RGB code. So that means red, green, and blue colors are going to be mixed together to create the whole color spectrum. So for example, if we want a red color, we have to set red to 255, which is the maximum level of red, and then green and blue to 0, which is the absolute minimum level of green and blue. And so that will create a red window. So we can try it right here. I'm just going to put this to 25500, and with this CV2 library, we're going to be able to create some windows. So set the color, and then in this code cell, there's 6 steps to create the window and fill it. And it looks like this. Now you got a red window. Now what happens here is that we first create a window in CV2, and then we start a window thread so that it is active. And then we set the height and the width of the image that we want to create. So the image is basically what we fill and then put into the window. We create the image, and then we fill every pixel in that image with our color. And then we show the color, so we tell the window, now show that image. And in this case, we then wait 3000 milliseconds, so 3 seconds to show the window, and then we close it with this last step here. So we can try it again. So for example, here, if we set the color to 255, 255, and 255, there should be white. So I'm just going to set the color as this, and then I'm going to run this cell again. You might want to watch out, depending on your system, the second time you run this cell, it will open the window behind the browser window, so just make sure you got that going. Maybe let's try a different color here. So I think, yes, that's going to be pink. So a whole bunch of red with a whole bunch of blue together is going to create a pink color. Okay, that's section 1. In section 2, we're going to create some random colors. And for that, we're going to use the random package and define a function called generate random color. So that one, for each of the red, green, and blue, is basically going to throw a die, and then it's going to take the number between 0 and 255 on that die and return it to us as a result. So I'm going to define a function here, and then I'm going to give it a try. So here we got 1, 2, 3, 7, 5, 2, 5, 9. Let's do it again. So 205, 219, and 203, so it's probably going to be quite close to white. Let's just take the code from before where we created a window, but we're going to extend it here with a loop. So in this loop, we're going to go through 20 iterations, and in each iteration in the beginning, we're going to generate a random color. Then we're going to take that color again, put it in the image, and put it in the window. So let's see how that goes. Here we go. Looks a little bit like a disco. And so now we got the window and different colors, 20 of them randomly selected, displayed on there. Okay, let's jump to section 3 then. So that's about setting the goal color and calculating the arrow. So in the SDL for Kids, our task will be to find the color that's closest to a target color. But the catch is, we don't actually know what the target color is, or more precisely, the computer doesn't know that. So for example, to figure out whether 2 colors are close together or far away from each other, we basically have to take the difference between the 2. So for example, when we have a color here that is our goal, so that would be red again, and we have another color that we want to know how far or close it is to it, we basically have to subtract the red part from each other, the blue part from each other, and then the green part from each other. And so we can do that here with a function. I'm going to call it calculate arrow. And so I'm going to define that, and we can just give it a try here. So if we have these 2 colors here, the goal color and the current color, then the difference between these 2 is going to be 0 because they're identical. Or for example, now if I add, let's say, 100 on the blue part, then the arrow is going to increase because my goal target color doesn't have any blue, but my current color that I'm interested in has 100 blue. So that's going to be an arrow of 100. And so I guess the color that's furthest away from red, or our target color here, would be 0, 255, 255, and that has an arrow of 441. Okay, let's just take again our window from before, where we are putting in those random disco colors. And on top of that, we're also gonna calculate the arrow here and put it into our browser window. So I'm running that here, and we see that for every different random RGB color, we also get our arrow calculation. And so in this case, our goal color here was 255, 0, and 0. So we see, for example, that if we have a high arrow like this one here, that means we have a low red part and high part of the other ones. Whereas someone that's a bit closer, for example, this guy here, so that one has a lot of red in it, but not so much of green and blue. So that's confirmed. What we also do is we carry along all the arrow values so we can plot them. So this is just a list called arrow values that has been already put in the loop before. And now we can just use this cell here to create a plot. So in this case, actually, the color that we randomly selected is the closest color, is the first color straight away. So if I run this random generation of color again, we will probably get a different result. So here, the first color was the best color, or the closest color to red. And then if we plot the result for this run here, we see that actually, only about step 13, 14, we get the best color, or the color that is closest to red. Okay, so as a final step in section 4, we can add some more context variables to the screen. So for example, here we plot the goal color, so that way we can easily verify visually which colors are closer and which are further away. We also show the iteration, so which color we're plotting, and then the arrow for the color. Okay, well that's all for step 1 of our tutorial. In step 2, we're going to look at characterization. So that is where you use the microbit to measure color on the screen. And so you just continue with that, and I'll see you soon.